Good morning. This is our second video for week 2 for lab 200, and this one is going to be all about directional control valves. This is how we actually control components on a pneumatic system. Okay, so let's go through this PowerPoint and see what we've got. You can see that we've got ones that are manually operated, and these would actually be hydraulic valves. Over here I've got one that's called a solenoid. That's what this black square right here is. Operated. And over here we've got the same thing, another solenoid operated valve. So they come in different configurations, different shapes, different sizes, different colors, depending on the manufacturer. They all have the same things in common though. They have internal flow passages through the body. In other words, these have been drilled out or cast so that there are openings that pass air, in this case, or hydraulic fluid here, through the openings which are called the ports. The passages are connected and disconnected by a movable part. Okay, and for our valves, what we'll be looking at is what is referred to as a spool. There are also poppets as well, which is a component that can move up and down and block passages. Moving spool or poppet connects or disconnects the passages to control the direction of fluid flow. Now remember, they say fluid flow, they're also talking not only a liquid, like in an oil, but also air, which would be considered a fluid because it can pass through and take the shape of its container. Okay, when you're talking about the symbols for a valve, they actually start out with this rectangle, and that is what is referred to as an envelope. Okay. Inside that envelope, they will have in here, you will see coming up, that they have what are called ways or passages through the valve. So this is a single envelope. If I've got a 2-position one, it would have 2 envelopes. And of course, if there's a 3-position one, it would have 3 envelopes to show us each one of the positions or the ways that the air or the hydraulic fluid would pass through it. As far as our class will be concerned, these are the different ways through a valve body. There's a 2-way, there is a 3-way, 4-way, and we also have a 4-way 5-ported. In other words, there's 5 holes or passages in this. At any one time, we only use 4 of those. Okay. Each directional control valve will have at least 2 positions. Okay. It can't control direction with just 1 position. It has to have at least 2. Okay, and this is how we name the number of positions or envelopes, the number of ways. It says the number of ports involved in active circuit flow paths in the normal position. In other words, how many can we actually use? And even a 5-ported one, we can only use 4 of those ways. So the number of ports involved in the active circuit flow path. And then, of course, the number of ports on the valve body. Okay, so here's a 2-way. And you can see in this one, there are passing or non-passing, and obviously in this envelope it would be non-passing because our fluid would come to this point, would be blocked. That's what this little T stands for, and the upside down T means it's blocked in that direction as well. So this would be non-passing. Okay, so if I've got this as my normal condition, and we'll get into normal condition a little bit more. In the normal condition, this would be non-passing, or what is referred to in fluid power as normally closed. And you'll see that there's a little bit of confusion when you go to industrial electronics, where they're talking a little bit. They're normally closed means that it can pass. So for our purposes, rather than become too confused between the two different classes, we're going to refer to this as non-passing. We're not going to use the terminology normally closed or normally open. We will just refer to it as non-passing. Okay. This is our symbol for that valve body, and this is more of a pictorial representation of it. As you can see, here's an opening or a passage coming through the valve body. To get to the actuator or whatever it is we want to run, you can see at this point our spool, that's this cross-hatched piece here in the middle, is actually blocking the pressure port so no air can pass through or no hydraulic fluid can pass through and go to our actuator. So that'd be our non-passing. Once we shift it, you can see that now the fluid can pass through and go out, just like you see in this diagram here. If you look back on it, you can see that it was blocking it here. When I go forward, you can see that the spool has shifted to the left and now allows passage of the fluid. Okay. Okay, so a two-way valve provides on-off type functionality. Just what we saw there. It can either block it and not allow it to pass, any fluid to pass, or we can open it and then allow the fluid to pass through. And of course, it's usually used as a circuit shutoff valve. So another way to block or isolate a circuit. Two-position, two-way normally closed, or two-position, two-way normally open. And that depends on how we set the valve up itself. Okay. But it could be either or. And again, we'll get into that a little bit further. Okay, a three-way valve. You see that in this case is non-passing. The pressure is coming from the bottom. Comes to here, and it is blocked because of an internal block because of the way the spool is designed and set up. So you can see that it comes up here. It cannot pass by this area here because it is plugged off. And once and the other part of it, whatever we're connected to, and more likely some type of cylinder, you can see that it would be allowed to exhaust. And this would be used on one that would probably have cylinder that would probably have some type of either weight that would physically bring it back on its own, or it would have a spring that would return it to a retracted position. Okay. And now once we shift it, you can see that now in this envelope right here, we are actually allowing the fluid to pass through. Originally, it is non-passing, and once we shift it, it is now allowed to pass. Okay, so a three-way valve provides pressure and exhaust. Remember, our two-way did not allow us to drain or exhaust anything. Typically used for single-acting and spring return cylinders, commonly used for control of pilot actuators on other directional control valves. In other words, this is used in conjunction with another valve in the circuit. So it'd be a two-position three-way, normally closed, which is again non-passing, and a two-position three-way, normally open, which is passing. And again, don't get confused with normally closed and normally open. You can say a two-position three-way non-passing, or two-position three-way passing. Okay, here's our four-way valve. So it's got to have four ports, in other words, four openings of the body. You can see I've got one for my pressure, one for my exhaust, and then I've got an A and a B port. With our MAC valves, and we'll get to those, or you should have seen those in the other video, you'll see that we actually have 5 ports on ours, and we'll see that in the next couple more frames. You'll see a 5-ported one. Okay, so with this one, you can see that my pressure is being allowed to go out and go to or go through the A port, and again this might be connected to a dual acting cylinder, so I might be allowing the cylinder to extend. When the cylinder extends, the other side is connected to the B, so it would have to exhaust. If you look here, here's my pressure port. It comes up through here and goes out through the A. And you can see that the B can go around the spool here and come back out through the exhaust. When I shift it, you see it now, the pressure is going out through B, and my exhaust is coming back through A. And you can see that here. So with a four-way, we are actually applying pressure to one side or the other of our cylinder, and that cylinder would have to have, besides applying pressure to one side, it would have to have a way to exhaust the other side. So that's what you're looking at here with a four-way. So a four-way valve provides pressure and exhaust, and of course it flips those or switches from the A to the B side depending on which envelope we're in. And of course that would cause a reversible motion or a double acting cylinder. In other words, it would cause the cylinder to extend and retract. And of course this would be a two-position four-way, four-ported valve. So let's see, okay, the ones that we have on our board are four-way valves, but they're five-ported valves, and we will see what the extra port provides. And it says commonly used in pneumatic circuits, and of course that's what we'll be working with. So here, a four-way, five-ported valve. Here you can see it here has 5 ports in it, or 5 openings. I've got one here that's internally blocked. Got a second one here and a third one over here. I've got 1 and 2 up here. So if you look, pressure's coming up through here, going out through the A, and my exhaust would come down through B and exhaust out, in this case what they're referring to as port 2. When I shift that spool, you can see that now I'm in this envelope on the left-hand side. My pressure is coming up through the center port, going out through port B. Port A is exhausting through port 1, according to what they've got here. So in other words, here they're talking about flow paths. And how to switch back and forth is you have to switch the spool to various positions. You can manually actuate them, you can mechanically actuate them. In other words, the machine actually does it. When it's manually actuated, a person may do it. It might be a push button, could be a lever, could be a foot switch. Fluid actuated, of course with hydraulics it's oil, with pneumatics it's air. You can actually shift that. That's usually referred to as pilot. Pressure is used to shift it, and then of course it can have electricity used to shift it, and that's using an electric solenoid to shift the spool. So here's a directional control valve, manual valve actuators. So right here you see the body, and that is one envelope right here. That envelope has a 1, a 2, a 3, a 4, and a 5. A little different than our Mac valves. And then here is the second envelope. So this is a two-position valve. I've got one over here on this side. I've got the second position over here to the right of that. I've got a spring. That's what this zigzag line represents on this left-hand side. On the right-hand side, I actually have 3 different components. This tells me that I've got pilot air. This would be an internal pilot. That's what this little triangle represents. So this is air. This rectangle here with the diagonal line represents an electric solenoid. And then this final one that kind of looks like a shotgun shell, that represents a manual operator of some type. So when you look at this, you can see that I can do it electrically. I can physically go to this valve and push on it, or manually operate it somehow. It might be a push button of some type, or it might be like a screw, looks like a screw fitting that you turn a quarter turn, but it's going to open up an air passage which will shift our spool. But that's what you're looking at here. This is a complete symbol for a valve, and this happens to be a 2-position, 4-way, 5-ported valve. And in this frame, you'll see that they're actually showing us different types of manual operators. Notice there's nothing on the left-hand side, so we don't know what's there. On the right-hand side, they have shown us a lever, some type of palm or push button, a foot switch, and then a manually operated one, meaning that this could be some type of push button, or again, look like the head of a screw or whatever, depending on the manufacturer. So that's a manual override. Could be a mechanical plunger, rollers, cams, and so on, and they are usually represented by a circle on a shaft coming out. Here we're looking at some type of pilot pressure being used. Here, if that little triangle is filled in, it is hydraulic. If it is open like this one is here with just a white background, that is pneumatic. So this would have hydraulic pilot pressure. This would have pneumatic pilot pressure. Here's your electric solenoid all by itself. Again, a rectangle with a diagonal line. So now I've got an electric solenoid. Here's where we've added springs to this. And in this case, you can see that I've got my solenoid on this side and a spring return on this side. With this is a 2-position. With this 3-position one, and you can see that I've got 3 envelopes. Okay. I've got a spring on either side, and in this case, that would make sure that this valve would center in the middle. Okay. When I push the lever forward, I'd be in this envelope. When I release it, it would be in the center envelope, or if I pull the lever, it would be in the left-hand envelope. The springs determine its normal condition. When I talk about normal condition, I'm talking about which envelope it would be sitting in. So the spring side, as long as I'm not energizing the solenoid, I would be sending pressure from the center port to the right, and my left port would be exhausting. Okay. With this one down here, where I have springs on either side, again, that's going to cause me to center on the center position here. So the 3 envelopes, it puts me right in the middle. And because every one of these have a little T-shaped symbol, either upright or upside down, that means that those ports are internally blocked, so that these would not allow any type of flow or fluid to pass through the center position. That would be referred to as a normally closed center. Okay, let's see. Multiple actuators can be used to provide and or functionality. Stacking symbols provide or functionality. Placing next to each another provides and functionality. Not too concerned about this. You'll learn more about that as we go along. And again, just different symbols showing up here. We will gain more knowledge, obviously, as we go through this course. Here's a valve or a component that could be on a valve that we will run into later. And this shows you that we've got what are called detents. These little round circles that you see, you got 3 on this side and 3 on this side. That's supposed to represent a spring. This little ball that you see here is then spring loaded, so it keeps it in contact with this part of the component. So when the spool is energized, or when the spool is shifted to the left, you can see that it will travel up this is stationary. So as the spool shifts to the left, you can see it comes out of there and it will eventually drop into here. And what they're telling you, or what they are showing you here, is that with a detent, you don't need to keep that activated. In other words, if this was a solenoid that caused it to shift, I can take the power away from the solenoid and this would hold that spool in that position. It would not go back to this position over here until I energized the solenoid or actuated the valve to shift back. So in other words, it's going to hold it to wherever you place it. So just between those two positions is where you would have the capability to hold that particular spool in that position. Let's see. Here we're describing the value shown in the schematic, the valve shown in the schematic. Okay, so we know it's two position. How do we know that? Because I've got an envelope here. I've got another envelope here. Okay, four ways. Okay, we've got 1, 2, 3, 4. It's 5 ported. So I've got 1, 2, 3, 4, 5. Air piloted. That symbols a pilot pressure or a pilot being used. And I've got this open, so I know it's pneumatic or air. And then on this side, I have spring return. And that is the end of this PowerPoint. If you have questions, make sure you contact me and ask those. Thank you for listening. Bye.